Okay, so like I said in the last video, Leslie matrices are new in this study design. So they first turned up in the 2023 study design. Leslie matrices are transition matrices, but that look at animal population and birth rates and survival rates. So Leslie matrices count only the females in a population because only females give birth. So that's something to keep in mind. Leslie matrices only deal with females in a population. So they are created from tables of information that have female birth and survival rates for different age groups. So the first thing to do is to set up a table and decide on those age groups. That's very dependent on an animal's lifespan, which is the maximum time that an animal can live. So, for example, here we've got a golden hamster. Their lifespan is 4 years. So we might do 0 to less than 1, 1 to less than 2, 2 to less than 3, and 3 to less than 4 years of age. For this chameleon, though, we've got a 6-month lifespan only. So we're going to talk in months, not years. And we might do 0 to less than 1 month, 1 to less than 2, 2 to less than 3, 3 to less than 4, 4 to less than 5, and 5 to less than 6 months of age. If we look at a cockatoo, though, they live for up to 50 years. So we're going to try to make some bigger buckets of time, I guess. So this is years again, but we're going 0 to less than 10 years of age, 10 to less than 20. Can you see that we want to keep them at about this size? Any more age brackets than that, and our data gets quite difficult to handle. Too few, though, and we lose some of the integrity of our data. So be really mindful about how you are going to break up the age groups. So keeping them at probably, this 4 to sort of 6 grouping. But think about what is the most appropriate. It's hard to put a hard and fast rule on it. So we've got some lizards here. We've got the birth rate and we've got the survival rate, and we've got them broken up into those age groups here. So this is our Leslie matrix. So 0.2 here and 0.3 here. So this is moving from one age category to the next. So this would be your 0 to 1, less than 1, 1 to less than 2, 2 to less than 3, and 3 to less than 4. Okay, so when they are 0 to less than 1, the birth rate is 0.2, and moving from that 0 to less than 1, 0.3 going to move to that 1 to less than 2 age category. So this is showing how they are moving through those age categories. So what is the survival rate? So if they were here, what percentage is actually going to make it in the survival and survive through to the next age category? And then the top is showing us that like what they're going to give birth to. Okay, so what this is telling us is that on average, female lizards 0 to 1 give birth to 0.2 female lizards. So remember that this is talking about how many female lizards these lizards give birth to in a year. Once you've started reading these, they will make more sense. All right. Now, birth rates can be numbers greater than 1, but survival rates can't be greater than 1. So unlike transition matrices, the columns in a Leslie matrix don't add to 1. So just keep that in mind. So Leslie matrices are square that calculate female population. So remember when we're talking about that birth rate, it's only going to be births of females. Birth rates are given for each age group in that first row. And then the survival rates are given as decimals for each age group in the sub-diagonal. So that diagonal that is immediately below the leading diagonal. There are zeros everywhere else. Leslie matrices are based on birth survival rate tables, where the birth rate is the average number of female babies for a female in an age group. The survival rate is the chance a female in the age group will live up to the age of the next group. And the last survival rate in the table, which is always 0, does not appear in the Leslie matrix. Okay, so we are talking about capybaras. We've got 49 female capybaras less than 1 year old, of which 35% will survive to 1. We've got 62 1-year-old female capybaras, where 43% will survive to be 2. We've got 38 2-year-old female capybaras, which none will survive to be 3. So then we go on to their birth rates. So female capybaras less than 1-year-old give birth on average to 4.6 capybaras. Okay. Female 1-year-old capybaras give birth on average to 4.2 capybaras. And then female 2-year-old capybaras give birth on average to 2.8 capybaras. Now, this value here, so the 4.6 capybaras is both male and female. So in the later part of the question, it says that half the population is female and half of the births are female. So we need to divide this by 2 to get the birth rate of the females in the population. So remember, Leslie matrices only work on female population. So if you simply put these values in, you are dealing with male population now, and our Leslie matrices don't operate in that way. So why did we need to halve them? Because this value represents not just females, and we only want to operate with female values in our Leslie matrix. You might be given a different split for males and females, in which case you would do a different divisor here. Okay, so we've got our table here. We know that we're dealing with 0 to less than 1, 1 to less than 2, and 2 to less than 3 years of age. They were our age categories. We've got our initial number, birth rate, and then survival rate. So we knew from our question we started with 49, 62, and 38 in each of those age categories. Our birth rate was given when we took these values and divided them by 2, given that half the population is female. The survival rate was given here in the question. So we've got 35% will survive to 1. We're going to turn that into a decimal value, being 0.35, 0.43, and 0. So none move from being, none live to older than 3, or 3 and older. Okay. We are going to now write a calculation from the table that will show how many 1-year-old female capybaras are expected to survive to 2. So we know that we've got 62 that are aged 1 to less than 2 years old, and we expect that 0.43 will move of that into the next category. So all we're doing is calculating 62 times that 0.43 will give us 26.66. Now, you are not going to have, if you said in your solution 26.66 female capybaras would survive to be 2, it's technically wrong, because you are not going to have a portion of a capybara. You either have a whole capybara or no capybara. So you need to round it up to 27 1-year-old female capybaras being expected to survive to be 2. So moving into this next category here. So we're going to write a calculation from the table that will show how many female capybaras are expected to be born after 1 year. So that's where we're saying this is the birth rate, and this is, so if we've got 49 females and in the year they're expected to have 2.3 females birthed, we're going that plus this plus this. Okay, so this multiplied by this multiplied by this multiplied by this. Sum those to get 296.1. Now remember, we're not going to have a portion of a capybara, so we're going to round that down to be 296 female capybaras are expected to be born after just 1 year. That's a lot of capybaras. So how do we write it in our Leslie matrix? Okay, so remember we're doing each of our age groups. So the birth rate goes along the top here. So for each age group, we've got 2.3, 2.1, and 1.4, and where they are moving to each age category. So it has to be square, and our survival rates go along our our sub-leading diagonal. All right, and zeros everywhere else. So I think what gets really confusing is that you've got to have your birth rates running along that top row, and then the survival rates go in the sub diagonal and zeros everywhere else. Now, something to remember is that you're going to assume that half the population is female and half is male unless the question tells you otherwise. So just keep that in mind. Make that assumption that it's a 50-50 split.